National Institute of Standards and Technology is going to provide the motivation for the COE. Bruce Ellingwood, Colorado State University, will give us a short recap of the first 5 years' accomplishments and a discussion of the renewal. Results of the NIST COE collaboration will be provided by Maria Dillard of NIST. A short demonstration and discussion of open source Inquire version 1.00. It will be from Zhong Li. Chris Clavin of National Institute of Standards and Technology is going to discuss a data workshop summary from a workshop that occurred last year. Plans for community engagement will come from Shannon Van Sant. User groups, in-course seminars, and hackathons will be described by Dan Cox. And plans for years 6 through 10 will be discussed by John Vandelint. We will preserve some time because we want to hear from everybody. And so there will be a live Q&A via WebEx chat, and that will be directed by Jamie Paget and Jared Lorzell of National Institute of Standards and Technology. At this point, I would like to introduce Terry McAllister, who's going to talk about the motivation and goals of this program. Thank you.
Thank you, Jamie. As background and context for the presentation today, I'll address the following 3 questions. What are NIST goals for community resilience? What led to NIST research on community resilience and to sponsor the Center of Excellence? And how will NIST and the Center work together to achieve these goals? The Community Resilience Program has 3 goals: to develop science-based tools for communities, professionals, and researchers, to support resilience planning and decision-making for communities of all sizes, to conduct outreach efforts to inform community resilience guidance and tools, and to conduct disaster and failure studies and associated expertise in metrology to support the validation of these tools. You will see that NIST and the Center are both addressing these goals. The concept of resilience has been evolving over time. This slide highlights key hazard events and national programs that helped to shape resilience in the U.S. FEMA was first established in 1978 to consolidate a number of authorities that had been distributed among federal agencies. However, following Hurricane Andrew, which caused extensive damage to South Florida, FEMA was reorganized to emphasize emergency preparedness, mitigation, and response, all well understood concepts in our communities today. The World Trade Center and Pentagon attacks shocked the country and had impacts across the nation as centers of commerce and government were damaged. This led to the establishment of the Department of Homeland Security, which consolidated federal agencies and authorities to address the security of critical infrastructure. Hurricane Katrina and too many other hazard events to list here remind us that events due to natural hazards will always need to be addressed as well. The Department of Homeland Security has responded with national plans to help communities and laid the foundation for the current focus on resilience. How did these events inform the evolution of resilience at NIST? Following the 9/11 and Hurricane Katrina events, which NIST studied, the idea of impact to communities and regions, rather than a focus on individual facilities or groups, gained traction. NIST worked with national experts on these topics and formed a multidisciplinary program in 2015. Resilience actions over time, from planning to risk and vulnerability assessments to recovery, need to be addressed. NIST is working on developing guidance and tools to help communities integrate these actions. The Center of Excellence is an important partner for developing science-based tools that integrate physical, social, and economic systems. And this slide highlights two key concepts in our resilience work by NIST and the Center, linking social and economic services to a community's built environment and developing the data and science for improved recovery modeling and tools, which you'll hear more about. As a summary, NIST and the Center goals are to improve the performance of the built environment, characterize interdependencies between community systems, and to develop science-based tools for improving resilience. The goals for the first 5 years are listed here: an open source multidisciplinary modeling environment, Inquire, which has been developed, as well as developing standardized data architecture and tools, and a set of test beds and hindcasts to support validation. This has formed a foundation for the continued 5 years of work, which has a slightly shifted focus on decision science for Inquire, as well as measurement science, verification and validation, and technology transfer of resilience science and tools to users. So with that overview, I would like to introduce Bruce Ellingwood, a Center Co-Director, to review the outstanding accomplishments of the Center's first 5 years.
We're having an audio issue. Bruce, are you there? I can go ahead if needed.
No, can you hear me now?
We can, yeah.
Yeah, all right. Resilience science was at a fledgling state of development 5 years ago. And resilience science-based measurement tools didn't exist, and significant research questions still remained. And our answer was to focus the Center's work in the first 5 years on developing that measurement science. Next slide. Next slide, please. Our work was structured around three major thrusts. The first thrust was the means to an end. A program of this magnitude required an overarching structure. And Inquire, the interdependent networked community resilience modeling environment, provided that structure, uniting system-level models of physical, social, and economic infrastructure and databases to support community resilience assessment. Each of those three major thrusts had a number of objectives and accomplishments, and at one time or another, there were approximately 100 individuals, faculty, postdocs, graduate students, administrative personnel from 12 universities involved in these activities, plus nearly a dozen professional staff from the National Institute of Standards and Technology. Rather than to try to read through all of these, I think I will just focus my presentation on just a few of them so that you have some ideas to the breadth of what we've been able to accomplish. I'll talk a little bit about Inquire, a little bit about the test beds, hindcasts, and field studies that have been done, something about community resilience goals and metrics, functionality and modeling recovery after extreme hazard events, and finally risk-informed decision making. Inquire has a number of features that distinguish it from other platforms. Originally, it was intended to be used primarily as a research tool, but as time passed, the Center realized that for its advantages to be fully realized, it must be accessible to a broad constituency of users, particularly communities confronted with the complex decision-making that goes along with making investments in future community resilient strategies, researchers striving to advance resilient science, and others who, in their own way, will ensure its sustainability after the Center has finished its work in 2025 and beyond. Inquire is a complex programming environment, as you might expect, and this just shows a little of what is involved. It's built in a modular form. There are modules that relate to natural hazards, to performance of the built environment, social and economic impact, state of recovery modeling with a shell that allows decision strategies to be optimized. Users can use the core modules for hazards or for building functionality that are embedded in Inquire, or they can supply their own as their own particular needs dictate. Inquire is a work in progress. Its first release was in December 2019, and subsequent releases are planned at approximately 6-month intervals over the coming 5 years. To provide a structure for the development of the science embedded in Inquire, the center has conducted a series of test beds, hindcasts, and field studies, beginning with Centerville, which was initiated about 6 months after the center was funded, and continuing over the remainder of the first 5 years and actually into the renewal period. Each of these studies has a specific purpose and has components related to physical infrastructure, social science modeling, and economic modeling. And just the teams working on these test beds and hindcasts and field studies are all interdisciplinary in nature, which is a distinguishing feature of the NIST Center, Community Resilience. Physical infrastructure considered includes buildings, bridges, transportation infrastructure, water and wastewater, power, including electric and natural gas. The social science modeling and analysis tools developed by the social science team have focused, at least to date, on population, housing restoration, business interruption. And in the coming 5 years, will expand significantly based on community resilience goals that are identified through future community engagement. This represents, as Terry mentioned, a slight change in the direction of the center. A significant development in the economic modeling module has been the development of a spatial dynamic computable general equilibrium model, which determines the impact of a natural hazard event on a community in terms of disruption, losses in jobs, wages, and production caused by damage to the community's physical infrastructure. Many of the ideas that have been developed in the subsequent test beds were first tested in the relatively simple Centerville test bed and are reported in a collection of papers in the special issue of Sustainable and Resilient Infrastructure. Other test beds are documented in the papers and reports that make our website. Additional accomplishments, that were not originally anticipated at the time we began our work, included those listed in this slide here, and I'll talk very briefly about just a few of them, and Maria Dellard will conclude with a discussion of the joint COE NIST Lumberton field study. Next slide, please. Thank you. In order to measure resilience, for a community, one has to have something to measure. And the resilience goals of a community are based on social needs and objectives that are specific to the character of that community. Center researcher teams have tentatively identified 5 central goals and have begun the task of determining how to measure whether these goals have been achieved. You'll hear more about this activity later in the webinar when our plans for community engagement and outreach in the next 5 years are discussed. This represents a starting point for the building of our decision models and will expand significantly in the coming 5 years. Recovery modeling is another area that distinguishes Inquire as a resilience assessment tool. Recovery of the built environment of social and economic institutions and services and systems are highly interdependent. The center has invested significant resources in modeling recovery of these interdependent systems, including sophisticated mathematical and probabilistic approaches to model uncertainties in the stepwise recovery of physical systems. The examples in this slide here show the breadth of our recovery modeling efforts, ranging from functionality analysis of individual buildings and essential facilities such as schools and hospitals to the recovery of building portfolios using Markov chain models to step through the recovery process, which are keyed to the building functionality states represented in the ATC placarding system, which many of you, at least who are structural engineers, will recognize. And finally, the risk-informed decision-making is a significant feature of Inquire and a significant activity in the center, particularly going forward. These algorithms form one of the modules that are built directly into Inquire. They utilize the goals and metrics that we identified above, as well as the goals and metrics that will be identified in the coming 5 years in multi-objective approaches that connect with the CGE models and or with other social and economic metrics and measures. One of the significant accomplishments of the center in its first 5 years, and one that we really couldn't anticipate when we began our work, is the collaborative effort between the National Institute of Standards and Technology and center investigators to examine the impact on Lumberton, North Carolina, of Hurricane Matthew, which occurred in late September of 2016, and which was followed by Hurricane Florence almost exactly 2 years later. And these events provided an opportunity for us to initiate a so-called longitudinal field study on the impact of such storms on the damage and the recovery progress in a community. To my knowledge, this activity is virtually unique, and it's one of the lasting accomplishments of the center. And I'd like to introduce Maria Dillard, who is the acting director of disaster and failure studies at NIST, who will tell you more about the longitudinal Lumberton field study. Thank you.
Thank you, Bruce. Today I'm going to emphasize one of the most valuable features of the grant award that has funded the Center of Excellence, and that's the collaborative nature of this grant. So in 2016, NIST and the Center of Excellence jointly embarked on this field study in response to Hurricane Matthew's impacts on Lumberton, North Carolina. Hurricane Matthew came ashore as a Category 1 storm in October of 2016, and it impacted North Carolina's coastal and inland areas. The city of Lumberton that you see outlined in black in the map above depicts our study area, and the flood inundation areas in blue in this map on the left. Robeson County was among the areas where significant flooding occurred because of Hurricane Matthew, and around 5,000 people in Robeson County were placed in shelters and temporary housing as a result. And then all 42 schools and serving 24,000 children closed for 3 weeks. Since October 2016, as you see in this timeline graphic, the field study team has conducted 3 waves of data collection with a 4th wave of data collection planned in 2020. And this includes the data collection wave 3 following Hurricane Florence, which hit the similar areas in North Carolina and other states in 2018. And it impacted Lumberton yet again with a major flood event, causing the Robeson County schools to close this time for 5 weeks. This work has contributed greatly to NIST Disaster and Failure Studies program, which works to collect and analyze data on technical factors responsible for building performance and infrastructure performance, to look at longitudinal data on community impact and recovery, to test novel field hardware and software to improve damage assessments, and to identify best practices for these field studies, as well as for the approaches to the frequency of data collection. And finally, all of this work aims to recommend improvements to standards, codes, and practices based on field studies. So John, if you'll go back one slide for me, I'll just talk about some of the ways in which this novel field study data collection really came about and has influenced the way we think about field studies. So of the features, This was focused on social dimensions. The reason I've emphasized education and the school impacts is that really was a driver in the selection of Lumberton. So these social dimensions critical to community resilience was a real focus here. We have surveys and sampling plans that really work to ensure representation of the physical damage, the socio-demographics of the community, various housing types, and the different business sectors. We used structured social science surveys and engineering damage assessments that integrated both the physical and the social impacts and allowed us to track recovery over time. So all of these methods stand to improve the totality of NIST disaster and failure studies, as well as research conducted in other NIST programs, including community resilience, applied economics, and Hurricane Maria's program. So here you see a couple examples of the new damage assessment instruments that were developed as part of this field study. And you'll just note in the upper left that we use a standardized building ID that's going to allow us to link these engineering damage assessments with the social science survey work that we did for the same housing units. And in the next slide, you see that these instruments allowed for the collection of field data that can be used to generate empirically driven damage assessment heat maps, as well as flood fragilities that are used for both residential and commercial business, building archetypes for this community. In the next slide, so here you see that similarly we developed survey instruments that allowed us to quantitatively examine the multidimensional nature of business recovery for a community impacted by a flood event. And the work that was done to kind of collect this data then leads to the outcomes of these predictors of recovery for businesses. So here you see that in particular, things like customer loss had a higher effect magnitude on the recovery outcomes when compared to things like business, the initial damage of the building and the contents. In the next slide, you'll see instruments are also developed to quantitatively examine the multidimensional nature of housing recovery. So these various housing states and the descriptions associated with them are assessed in the survey instrument, and then analyses look at various predictors of recovery outcomes, including income, race, and ethnicity. In all cases, the data collection instruments and the frameworks that are being used to test the hypotheses we have about recovery are all transferable with minor modifications to other communities and other hazard event types. Next slide. The field study has resulted in novel field data for measurement and modeling, and this includes data on building and infrastructure performance in the aftermath of disasters and community impact and recovery through housing, households, businesses, schools, and government. NIST and the Center of Excellence have also been able to use the field study as an opportunity to assess field equipment and reconnaissance protocols that can be refined and employed in future events. The field equipment includes things like LiDAR, vehicle-mounted 360-degree cameras, data collection software and applications, as well as protocols like field team training, safety protocols, and our institutional review board protocol that was submitted for the field study. Next slide. The benefits of this collaboration between NIST and the center also extend to projects of the Community Resilience Program, including work focused on the measurement of community resilience. This NIST project seeks to identify new indicators for resilience and recovery that emerge from both empirical and model-based work. And then we identify ways to operationalize these indicators using secondary data and test their performance in predicting the outcomes that are associated with community resilience. Next slide. Another Community Resilience Program project that has experienced the benefits of the collaboration is work that's focused on the development of an optimization tool to support community resilience planning. This project used Lumberton as a case study to build out an interactive tool for searching alternative sets of actions that meet community resilience cost goals, given hazard and interdependency information, as well as socioeconomic information. This modeling tool will draw from the complex data and relationships included in Inquire to facilitate the decision search process. And one of the ongoing objectives of this field study is to document community interdependencies. This has required the development of methodology to support the investigation of many of the connections that we assume to be present within a community related to the physical, social, and economic systems. And this work has been achieved through sampling strategy that looks at the interdependencies, the data collection instruments that take these into account, as well as through analysis and modeling. After 3 waves of data collection, we have data capturing the interdependencies of power, water, communications, those infrastructure systems with the residential and business sectors in the community. And the data can be used now to refine existing models and to build new models for disaster impact and recovery within Inquire and ARC. This concludes highlights from just a small selection of the results of this important collaboration. And I'll now introduce Zhang Li, the Deputy Associate Director of the National Center for Supercomputing Applications. Thank you.
Thank you. I'm going to talk about open source Inquire released in December last year. Next. So I believe that the previous speakers already explained a lot about Inquire and the scientific aspect. So this presentation focuses on software and cyber infrastructure aspect. Inquire has a various components shown in the screen. The first important one is the Inquire Python library, which contains the analysis code which implemented in Python, and also visualization code, and also communication with the Inquire web services and some utility method. So a user can use PyInquire to script or work developing the code to model their risk assessment and their community resilience models. And Inquire web services, this is the web service implemented in RESTful service. There is several services within. One is a data, another one is a hazard service, another one is DFR3, damage, functionality, repair, restoration, recovery, the curve service, and also there's authentication services and things like that. And on top of the web services, because it's more the technical aspect of usage, so we developed a lightweight web application in Inquire, which we call web tools. It is called the viewers, so you're able to browse the data and the hazard and also DFR3 curves. I'm going to show you in my demo later on. And then you are in the Inquire lab is customized Jupyter Lab environment. You are able to use those kind of the component in one place. Next. So like I said, Inquire version 1.0.0 was released last December 20th, 2019. And then all the source code currently available at GitHub. So if you go to the link, github.com/in-core, then you are able to acquire all the source code. And whenever we have a release or bug fixes, all the available code are there. And you are able to look at some of our changes and all the history of the source code changes there too. For information, this is under Mozilla Public License version 2. And also we release the packages, Python packages, through the Conda package management system. So if you go to the link, it shows how to install the Conda packages on your machine also. Most important part is Inquire landing page. This is the page that covers the technical aspects of Inquire. So you're able to access to documentations and then viewers I mentioned, and Inquire lab, and all those useful information in there. Also, it gives you what's the current version and development of Inquire shows up in the summarize in this page. Also, in the release 1.0 last year, we include the 2 testbed analysis with the data, which are the Seaside and Joplin. Next. So since then, we actively developing Inquire version, and current release version is 1.3.1, and we will have another major release in the end of July that Inquire 1.5 contains more scientific analysis in there. So I'm going to give you a quick summary and update on these numbers. One thing note here is that the 1.3.1 is overall version of the Inquire, but we have a separate versions for each component. You can find it here and also landing page. Next. So these are the highlighted of the update since last year release. So the Inquire Python library, we improved the parallelization code, processing the fragility-driven damage analysis. And also we added a local fragility mapping services that you are able to dealing with the mappings between the inventory to the fragility curve and locally. And then web services 0.6.4 has a new attenuation function for earthquake hazard service. And web tools, we improved the fragility viewer into DFR3 viewer, also allow you to see recovery and repair and restoration curve in the viewer. In terms of documentation, we added a getting started page. I'm going to show you in my demo. And this is very useful, a single page that you can go through step by step. You are able to use in Core. And we also regularly updating frequently asked question page. Next. So after this release, we are actively working on what's next. Usually we try to release minor versions in monthly or bi-monthly. So in Core, you're going to be able to use a local DFR3 curve, which means that you don't need to use the web services. If you are testing your fragility curve, you could create your own local curve and locally and testing with another analysis if you want to. And we're going to have a more better robust geospatial visualization through the visualization package. And another major release major feature will be we're going to support conditional and parametric fragilities in our service. And obviously, we're going to add some tutorials and tips on documentation. Next. And demo.
Okay, you should be able to share.
Please let me know you're able to see it.
We can see it.
Great. So what you see right now, this is a landing page, incore.ncs.edu. If you are interested in more scientific aspect about Inquire or Center of Excellence, please go to Resilience, Community Resilience COE page that you are able to find more information there. So this is a site we are more focused on technical or software aspect of Inquire. So first thing you're going to see here is a versions, Inquire version and also component version here. Also notice that there's a link available. So if you click on change log link, it actually shows that what kind of changes already done throughout the development and summarized here. And also if you click on GitHub, it goes to the GitHub repository to show all the source code you're able to access. And the conda package is a package page that you're able to see. This is a command line you can type in on your conda, you're able to install Inquire. If you use the update instead of install, it actually updates the Inquire if you already installed Inquire in your system. So I'm going to show you the documentation, which is very important. So Inquire manual. If you go in here, it has introductions and a lot of information here. But most of the very important aspect, especially your first-time user, you need to go here, Inquire accounts. So this shows that how you are able to acquire the Inquire accounts for free, and you can sign up and you are able to access web services and other services in Inquire available through web. And then the getting started page. This is a good page. If you're a first-time user, it actually shows the step-by-step how you can install, how you can use Inquire and Inquire. There's some example code you can actually run as a test run, things like that. So this is going to be very good documentation if you start first time. And then more detail about Inquire, it has explanation about analysis. So for example, this analysis, like a building damage analysis, it shows that what kind of input you need to run. And then also there's a snippet of code. You can cut and paste in your code, or there's a notebook example you can download and try out. And most importantly, we do also have released these two testbed Jupyter notebook. So Joplin testbed and Seaside testbed. So if you click on it, it is currently, it looks like a documentation view, but this is one directly converting from the Jupyter notebook to documentation system. So it has all the snippet of code, some data, and some analysis, and even the description about some of this analysis and some of the conclusions they have. And if you want to try out, if you go to example notebook page, bottom, there is a zip file you can able to download these notebooks. So you're able to run, if you have the Inquire installed in your system, you reproduce this analysis on your local machine also. Having said that, I'm going to show you the demo of the Inquire with a Jupyter Notebook. So what I'm going to do today is I'm going to show you the snippet of code that how you are able to do building damage analysis with the earthquake here. So you can see here some of the code you need to set it up as a client. And then now you are able to set up some variables. This is pointing to the web service that what kind of earthquake you want to use. This ID shows that this is new method earthquake 7.9 and then building inventory. I'm actually making this one is empty because I want to show you the viewer. If you go to here, there is a data viewer. And then if you see data viewer, there's a lot of data here. I'm going to search on hospital. And I found the hospital data here. So there's a metadata available. If you click on preview, it shows there's some dots, this location of the hospital location in the Shelby County in Tennessee. So I'm going to use this one. Then I can click copy ID. And going back to Jupyter Notebook, and you can paste the ID here. Now you're going to use that data from our service, and then click next, and then you are able to look at a little bit of the data here, how the building inventory data looks like. So I'm going to visualize the building inventory data by structure type. So the hospital buildings with C1, C2, several building types shows in this map and geospatial visualization. Or you could also visualize in an interactive way. This is called, so you can actually zoom in and out the area you can look at and things like that. So this one also provides interactive visualization of geospatial data. Then this is the part for the building damage analysis. You are able to see that you can instantiate the building damage analysis, and then you need to set up this analysis. So input data set going to be your inventory. You have a hazard type, this earthquake ID, and the mapping wizard name. You're going to use number of CPU 10, and then you're going to set, and then you can run analysis and either run the analysis for you. After that, now you have acquired the result from the analysis. You are able to look at quickly. So this shows that just the top 5 rows from entire data set. It has columns here. The first 4 columns are damage state, and then 3 columns are limit states. And there is a demand type of that building, and also demand unit, and what's the hazard value and the location with this earthquake. You can also sort this table to see some quickly. So I'm going to sort this data by the complete limit state, and then also sort ascending order. So you can see that complete values are ascending order here to see what's the top 5 of the rows or buildings you can look at. And obviously, you can also create some charting using the pandas library and plot library. This shows the distribution of complete damage distribution here. And then after that, now you have those damage states. You want to compute some of the mean damage. Then there's a mean damage analysis. You can set it up. You are able to run, and you are able to compute the mean damage. You can notice the very similar way to run the analysis here. I'm going to run the analysis, and then let's look at some output data sets similarly. So you are able to see at the last column has the mean damage and also mean damage deviation. So you're able to see that each building's a mean damage value here. And then if you could describe this, which means it shows some statistical value, there's 22 buildings. There's actual mean of the mean damage and also other information here. For sake of time, I'm going to go a little bit quickly. This is another way of visualizing. So you can compare 2 columns. One is a hazard value and the mean damage. So you're able to see the scatter plot of these 2 variables. Another one here is a Monte Carlo simulation of probability based on the damage probability we computed before. So there's several ways to do, but last one I can also show you that is some of the output visualization on maps also. So you can see some dots. That's the value of some of the outputs, mean damage value or probability failure probability of the value. So just last slide here is this is another visualization in Joplin testbed you can acquire. So this shows that there is a tornado path going through, and then how the building's failure probability distributed around the tornado path like this. So using this Inquire, you are able to do this kind of analysis, and you can have a more analysis information on the documentation. Can we continue to the last slide, please? Stop sharing.
Stop sharing, please.
So my last slide, when the slide coming up, is about how you can get support use of a Inquire. So basically, how you can contact to NCSA team for development team. There are several ways. The one is basically 44, slide 44.
Sorry, having some problems here. Thank you.
Okay. So documentation is the most important part. I think that we try to update documentation regularly. So this is the first place. Please visit and look at it. And you can find some of the the solution for your problem. Please also email us, inquire-dev@list.illinois.edu, or you can send us an email that we can add you to our Slack channel. So you can chatting with us and share your problem screens and things like that. And then we do have currently monthly technology meetings for Center of Excellence. However, I think we have some plan later on to open up that to the public. Thank you. Next slide. So next presentation will be Chris Clavin from NIST.
Thank you, John. John, if you can't hear me, can you hear me okay, John?
We can hear you great.
Okay, great. So I'm Chris Clavin. I'm with the Community Resilience Program at NIST. I'll be talking a little bit about a jointly held workshop and co-authored report between folks in my group in the Community Resilience Program at NIST and also the Center of Excellence. So I'll be talking about information that's in a report that we published, and I'll say this a number of times just for folks on the phone. I'll spell it out. The report, if you want to get it, I checked that this link is active, the shortened link is active. You can go to tinyurl.com/resilience-data-info, and I will say this at the end as well too. Next slide, please. So in October 2018, so a little bit over more than a year and a half ago now, we brought together a pretty diverse group of folks from researchers from academia, researchers and program implementers from government, also non-governmental organizations as well as practitioners from the private sector, and also community officials that are responsible for emergency management, disaster preparedness, resilience planning overall. And we were hoping to bring together this diverse set of folks to do, I'm mentioning here on the slides, gain a more complete understanding of what the current decision-making processes are and what are the different types of processes communities currently go through when they say they're conducting a resilience planning activity. What type of data and information are they currently bringing into that process? And then are there common data needs across communities that we can begin to generalize? And then are there different types of analytical tools that are being used as well too? So we brought together this group. We were really looking to begin to collect this information, share it, but then identify where there may be issues that collectively could be addressed by the research community, working together with practitioners, working together with community officials as well. So in the report, there's much more detail, but really quick takeaways. Communities and community officials seek practical approaches and methods to develop resilience plans and interact with their stakeholders. In particular, because many of the data that these community officials are trying to bring together to do their own analyses, they're bringing together, as we're dealing with as researchers, a large set of interdisciplinary, multidisciplinary data, some data standards that would help for the types of data standards that help the types of analysis we're considering would be helpful. And then as well too, this analysis to actually implement the findings of the analysis and the priorities of communities is they need funding to do it. And so they all need to identify funding opportunities, time them to describe the economic benefits and costs of projects they're considering. Next slide, please. So this is a really quick description of major findings and takeaways and things that we heard in the workshop and we heard as authors of the report, that these three core groups, practitioners, researchers, community officials, could work together on to advance the state of research, and particularly the state of moving research into practice in this field. Pulling from the prior slides, is a few I'll highlight. On the prior slide I mentioned community officials are seeking practical approaches and methods. So they want practical, scientifically grounded methods, and some of the things that resonated with that are a core set of community resilience indicators and metrics, or standardized, generalized approaches to community resilience planning. I mentioned previously resilience data standards to establish the foundation for analyses and assessments, in particular trying to bring in social, economic, but also the physical dimensions of communities are needed. And so some of the things highlighted on this slide relate to methodology for aggregation and disaggregation of data from these many sources that communities are responsible for integrating. But also as well to trying to find opportunities to increase the frequency and collaboration between both the users of the users of tools and the researchers or the practitioners that are developing them. And then lastly, we talked about optimization of funding opportunities and evaluating the economics of resilience projects. And so a couple things on here that are relevant to that are trying just increasing awareness of funding opportunities and the optimal timing of those resources. So trying to figure out standardized ways to think about how we can describe the timing of those resources. And then as well to increasing the availability of economic decision support tools and the attendant quantification, the research that supports the quantification of co-benefits that go along with these projects. Next slide, please. So again, if you'd like to learn more, you can go download the report at the links there, and there's a couple others as well too that may be of interest to folks. Again, for the folks on the phone, the shortened URL, which I checked before the talk is active, is tinyurl.com/resilience-data-info. Okay, next slide, and I will turn it over now to my colleague, Shannon Van Zandt.
Hi, folks. I want to build a little bit off of what Chris was just talking about. During that workshop, one of the things that became very clear is the need for a robust community engagement piece for our next 5 years. And so as we were developing the proposal for this upcoming 5 years, we began to work really hard on how we could use the communities that we were already engaged with and potentially engage more communities to make sure that Inquire is really what they need and that it will be both usable and understandable by them. And so a big task that we have going forward is to engage the community to ensure the usability and usefulness of Inquire as a tool that informs resilience planning and decision making. We both want to engage stakeholders in the development and testing of Inquire and also work with them to validate the models that are included in Inquire to make sure that those models are producing results that are meaningful to the community and that can support decision making on the ground. Next slide, please. So we are in the process of selecting. We are hoping for 6 case communities. We will be selecting them later this month or next month. And our first step will be to develop case profiles to understand what their past history with disasters is, what their local capacity is, and that sort of thing, so that we can go into a community with a good understanding of the issues that they're facing. We will also be interviewing case community stakeholders. One of the things that I recognize in my work is the importance of engaging with local stakeholders to make sure that the questions, the research questions that we're asking, are the questions that are important to the community and that the results that we get are meaningful and interpretable by them. Once we are engaged in the community, and we do plan to keep constant contact with them, to visit them a few times a year, we will be coming back to them from time to time to run default scenarios and test out the policy prescriptions that are being developed in the Inquire environment, and to test the usability of the models in the conditions that the communities themselves are experiencing. We also expect to partner with community stakeholders to get them trained on Inquire. Our hope is that Inquire becomes an indispensable tool for communities to use disasters in their community. If there is anyone on the webinar that is potentially interested in participating as a community, feel free to reach out to me at the email address that you see on the screen. We do have some criteria that we're using to choose communities, but we want to make sure that if you're interested, that we can give some full consideration to that possibility. Next slide, please. So what we'll be looking for first is the interest and experience in working with the Center of Excellence. So some communities that we're already engaged with are good potential candidates, but there may be additional communities out there that are interested in working with us. We also want to look at different hazard types. So not just flooding or hurricanes, but also potentially tornadoes, wildfires, earthquakes, tsunamis, drought, and maybe others. We will be looking at the capacity of the community to do resilience planning and kind of their demonstrated interest in resilience planning. While we want to work with communities that may have lower levels of capacity, we do need to make sure that they have the capacity to work with us over a period of time to be able to test out these different scenarios and contribute to our thinking about how we're modeling things. We also will be looking at data availability. That's one reason that we are focusing on communities that we have some experience with, because we're more familiar with the availability of data there. But there is kind of a baseline of data that is necessary for us to do the work that we need to do. And then, of course, we will be looking for some variability among communities based on their size, their geographic region, their government structure, their jurisdiction level, cities versus counties. We'll also be looking at their population growth rate and want variability along that, as well as some differences in economic prosperity. Next slide, please. The people that we will want to interact with will include decision makers, so elected and appointed officials, housing and other kinds of advocates or local champions, emergency managers, floodplain managers, public works directors, city managers. And we understand that different communities have a different array of these stakeholders, but these are just the kinds of decision makers that we would be looking at. We would also want to engage with people in the city that might want to use Inquire, and that may be planning staff or other technical staff like GIS staff and city departments and utility companies, as well as consultants who would be hired by communities to do the type of resilience planning that we are supporting. Next slide, please. So this last slide shows you kind of our plan going forward. And we have developed a description for an engagement outreach coordinator, who will be the one who is the liaison between the research team and the community stakeholders. We hope to have that person in place this summer. And then we will begin developing profiles of the case communities. And then over the next 2 to 3 years, we'll be collecting their input about their needs, meeting with them regularly to help understand their reactions and gather input into how Inquire is being developed, as well as to identify gaps in the Inquire metrics and models to make sure that we are producing the things that communities need to inform their resilience decisions. Thanks, and I'm going to hand it off to Dan Cox.
Thank you, Shannon. My name is Dan Cox. I'm a professor at Oregon State University. And to help wrap things up for the webinar, just kind of reinforcing how people can be involved in the center. You heard earlier, one thing that really sets Inquire apart is that it's an open source modeling environment, meaning that it's available to researchers and practitioners, both inside and outside the center, so that you can add to and benefit from Inquire. So consistent with that, we have user groups, and Shannon really did a great job describing user groups that are formed through community partnerships using in-core output, for example, for decision making, providing the types of inputs that are needed. And then also there's another type of user group, which are, you could say, more of the core researchers, the programmers from academia and government agencies. We're interested in reaching out to everyone. We have some contact information on the slide, resilience@colosstate.edu. And there were also 2 emails that flashed up earlier. One, if you want to contact Shannon directly, and to contact John directly. But either way, if you see yourself in these user groups, please contact us. Some of the things that we've established in years 6 through 10 is having a well-defined in-core webinar series. Again, 2 types, sort of following with the theme of the 2 different types of user groups. One that John had mentioned earlier are the in-core technical sessions. Initially, we're starting with just the membership within the center, but have plans to expand to include people from outside the center who are actively using Inquire. So currently this is on the 3rd Tuesday of every month, starting at 2 p.m. Eastern time. Shannon also, she just explained some of the community engagement, and we'll be holding regular webinars, at least quarterly, for resilience professionals to just spread the word and try to build the community around Inquire. Next slide, please. And then one of the other really great ways to build the capabilities of Inquire, the functionality, and as John described earlier, to make it both useful and usable, is to create hackathons. I'm sure many of you are familiar with the types of hackathons where, for example, a group of computer scientists, researchers get together and try to implement some of the Inquire functionality. And then also we're envisioning science-based, community-oriented hackathons where it's not really necessary to be a programmer, but just really excited about particular problems that a tool like Inquire could help solve with. Looking at a timeline starting around late fall 2020, and ideas are welcome. So again, reaching out, we have some contact information on the slide for you. So that's it for me, and I guess back to John.
All right, well, thank you, Dan, and everyone. So as we bring the presentation portion of the webinar to a close, I'm pleased to be able to share the center's plans for years 6 through 10. As you've heard, a large focus is on community engagement, making Inquire usable and useful for communities at risk of natural hazards. The COE's vision, as you heard earlier, is that Inquire will serve as a tool for communities to engage and benefit from risk-informed community resilience planning. It will be fully validated and integrate the disciplines needed to successfully plan for and mitigate hazards, and enable decision makers to evaluate alternative actions and policies for their specific needs. As you've also heard over the last hour, the center consists of 14 university partners and NIST. In years 6 through 10, we'll focus on 3 major thrusts, which include Inquire for community modeling, which you're hearing a lot about now, data science and field studies, and then decision support and user engagement. Standardizing data formats for use in Inquire in collaboration with others working in the community resilience space is key to broadening the use of Inquire. It includes the validation through test beds, including a new Mobile, Alabama test bed, which adds multimodal transportation capabilities to Inquire. We'll be continuing work on the Joplin Tornado Hindcast, which is one of the Inquire Jupyter Notebook examples from the December 2019 release. John just talked about that in the version 1 demo, as well as the Lumberton, North Carolina field study. It will be continuing on for at least 4 more years, a summary which is forthcoming in a natural hazards review paper. Decision support algorithms informed through extensive community engagement program with these 6 partner communities discussed by Shannon is really a major and new and major undertaking in years 6 through 10. The center's work in years 6 through 10 is focused across 6 major tasks, each of which has a number of subtasks with integrated workflows. Task 1 focuses on the development of Inquire itself, includes a scientific integration committee called SciComm that prioritizes algorithm and data integration, standardizes inputs and outputs, and works to engage user groups with technical seminars and hackathons that you just heard about. Task 2 leads the engagement of our 6 partner community, discussed by Shannon, which, while working on development and execution of a business plan to ensure Inquire is sustained for use by communities beyond year 10 of the center. The mitigation and recovery task develops policy and resource portfolios for integration into decision support algorithms. It's critical that algorithms, data, and all components within Inquire be validated to ensure accuracy. Task 4 focuses on the development of these processes for the center, the validation of recovery models through field and other studies such as the longitudinal Lumberton study, partnerships with NIST researchers, and testbeds, which I'll introduce shortly. In Task 5, 2 types of complex systems will be incorporated into Inquire: intermodal transport and social institutions such as schools and hospitals. Risk-informed decision-making at the community level requires that uncertainty be propagated through the algorithm, which in turn requires proper resolution to ensure an accurate enough representation of physical, social, and economic systems. These uncertainties and resolution studies, combined with standardizing interdependency models within Inquire, make up Task 6 of the center. On previous webinars, we've introduced testbeds, including the Virtual Community Centerville, Seaside, Oregon, the Memphis Metropolitan Statistical Area, known as MMSA, and Galveston, Texas. The newest testbed in the center is Mobile, Alabama, which will help drive algorithm development for the multimodal transport, including ports, railways, and roadways, and their interactions. Joplin, Missouri was the major hindcast within the center, and Lumberton, North Carolina, the major field study, documenting the recovery of a diverse community now in its 4th year. Seaside and Joplin are already available in Inquire, as you heard, to serve as examples or to change and use within your own work. Galveston, MMSA, and Centerville should be coming soon. So as a reminder, as Jung mentioned, Inquire accounts and support are available, and you can always go to Resilience, the Resilience website as well, the center website, and follow links. And so on behalf of the center community, thank you for your attention, and I now turn you over to Professor Jamie Paget and Mr. Jared Lorzell for the Q&A portion of the webinar.
Thank you, John. Well, good afternoon, everyone. Jared and I are here to help field the Q&A portion. We still have about 10 minutes left in our webinar time, and we welcome you to submit any questions that you might have through the WebEx chat window. I haven't seen any come in throughout the course of the discussion, but now would be the time to submit your burning questions.
And I think if you need to do it verbally for some reason, I think that'd probably be okay too, Jamie, right? If they just need to ask.
It would. If you have adequate audio, please feel free.
Hi, this is Glenn Bell. I have a question for Shannon.
Thank you, Glenn. Please go ahead.
Sure. Shannon, I'm really interested in the community engagement piece. I think that's a great thing to be doing. And my question goes to the data that you will need to engage with communities that the center hasn't worked with to date. Can you describe for us what level of detail that you will need to run useful exercises? And I come from the structural community, so I'm imagining trying to model, for example, the physical infrastructure. How much detail do you need to be meaningful? How much work is it to collect that data? And how will you do it in a community where you haven't worked before?
That's a really good question, Glenn, and I may not be able to answer it fully today, but I think, yeah, you're mentioning a lot of things that we will need. Definitely, we would want to see a baseline of parcel level data. We often start with a tax appraisal data just from a land values perspective, but we would also hope to have the structural data that we could use to identify the types of buildings and the footprint of buildings. A lot of communities may have that in property card data, and they may have their own, we hope that they would have their own database of some of the structural characteristics. Some of the engineers and economists may be able to kind of chime in here and indicate kind of what the baseline would be. We probably would not be in a position to collect a lot of primary data, so we would depend on the city to have existing data sets, hopefully already in a GIS that we could, export and import into the different programs that we're using. Does Harvey or maybe Elena want to chime in on the other types of structural data that would be needed?
Sure, this is Harvey. Yeah, for any town, in terms of structural data, there's always the building department, which can have data on a lot of different individual buildings. We talked about this private company called Atom Data, which supplies county assessors data. It's a data for every parcel in a county, but more than that, it has the types of buildings on each parcel, whether it's commercial or residential, and even the types of materials like masonry, steel, or wood. So there is data out there at different levels. Mostly I'm interested in economic data, but again, the county assessors data gives at least you a picture of all the types of buildings in a community, whether it's 1-story or 2-story, and that will impact fragility curves. So the Atom data costs money. Sometimes county assessors offices actually have the data for free, but it's not as rich as the Atom data, which they augment it with a lot of other sources. So I don't know if that helps a little bit.
I think, Jamie, I could respond from a structural standpoint, and maybe Elena wants to too. But, Glenn, one of the things that we're doing in this, in fact, it's already going, is looking at that kind of complex relationship. Trying to quantify, when a decision can be made and be useful to a community versus, what the quality or the quantity of their data that they have available is, because all the communities, as we'll hear in the later on in discussions, their capacities are very different, like Shannon was saying, and so it involves a sensitivity of when you're assigning fragilities and to a certain building type, and of course it could be a function of hazard and things. So it's underway, but it's definitely a research question.
Thanks, John. And I think we have quite a few questions streaming in through the WebEx chat, so perhaps we should move on to one more question. Jared?
Yeah, Jamie, thanks. This is Jared. I'm going to go ahead and read a question that we have from Matt Heyman on the chat. I'm going to focus this at Shannon first, and then anybody else that might want to chime in from the test beds, perhaps. How have you coordinated with city and county officials in those multiple communities you are already working with? And that question again was from Matt Heyman.
Yeah, I see that. That's another good question. I think it varies from community to community for sure. But a lot of the communities that we're already working with are places that we have had longstanding relationships with. Galveston is my best example because it's the one that I've worked with most closely. But I've been involved in Galveston since 2008 when Hurricane Ike hit. And we've worked with them extensively. We worked with city officials. We worked with their long-term recovery group. I have connections to some of the citizens groups on the ground. I have former students that work there. And that's also an advantage for, at least from my perspective as an urban planner, trained as an urban planner. And many of us have former students that work in many of these communities, and that's always a great place to start. It is really important for us to build trust-based relationships with the communities that we're working in. And we do have kind of a community covenant that we expect to use that outlines kind of what our agreement is, what we expect from the community and what they can expect from us. And so we will, part of our interest in hiring a community engagement coordinator is to have someone who can develop and maintain those relationships so that they are in the best interest of both the community and our research team.
I can add really quick for Lumberton too. Hi everyone, this is Elena Sutley at the University of Kansas. And so with Lumberton, part of our team does do interviews. Sometimes these are formal, sometimes these are informal and more like conversations. But each time we go into the field, we schedule meetings with different people within the city, including with the schools, with public works, with the city manager, and even the state emergency management office. We try to send the same people on our team to do those meetings so that we are able to build on that relationship each year. And then we also publish reports after our field studies. And so we share those back with the people we do the interviews with, along with other types of information about what we're learning in their community.
Thank you, Elena. We are reaching the end of our webinar, so I think perhaps we have time for one last question, and we will try to follow up with responses to some of the lingering questions. We had a question from Rishi regarding some of the baseline performance levels. So when assessing resilience of a community, how are you setting baseline performance levels from socioeconomic perspectives? And I thought that perhaps Harvey and Nathaniel may speak to some of the data sources and baseline information that we're building some of our social and economic models from. Harvey, can you get us started?
Nathaniel, since I've been going back and forth with all my data, you may want to chime in with a different perspective.
Okay, this is Nathaniel Rosenheim at Texas A&M University, and just quickly, what we primarily are using data from the decennial census and the American Community Survey, as well as linking that to some of the economic data that provides information on employment. We look at try to do intersection of race, ethnicity, tenure status, household characteristics, to see where community populations are living, and then through our housing unit allocation, which is already part of Inquire, identify which populations are living in different structures and see how they're impacted by the hazard event and then disruptions in functionality. So we are depending on publicly available data and then informing our models for things like population dislocation through our primary data collection in past hurricane and natural disaster events, as well as the Lumberton field study data that we're collecting.
Great, thank you, Nathaniel.
All right, thank you, Nathaniel. Looks like we're about right on time to wrap this up. I'm going to go ahead and send this back to John Vandalen. Any questions that are left in the chat, or if there continue to be questions posted in the chat, we'll make sure that those are forwarded to the appropriate people, team members. But again, thank you very much for all your questions and increased or continued interest in this project. Over to you, John.
Okay, thanks everybody. And and James Newman, I was responding to your questions so interested as I'm done talking, and saw your question on there that we didn't get to. So thank you for joining the webinar, and we'd love to have you, to reach out to us for additional information. And we'll be hosting probably a longer webinar next year where we're all in the same place, and sometimes the production is a little bit more refined. But thanks for attending, and feel free to reach out to the resilience address or to anybody individually within the center to communicate. And we hope you'll consider using Inquire. And if you're a community, we hope you'll get in touch with Shannon and consider partnering with us. So thank you.
Thank you, John.
And James, I will respond to you right now.
Thanks, John. I'll shoot you an email as well.
Okay, yeah, maybe it's easier by email instead of the chat. So yeah, if you want to send me an email, James, I'll give you a better response than in the little chat here. So, okay, thanks everybody.